Given three mutually independent events, A, B, C, show that A and the union of the remaining two are independent. What does it mean that A, B, C are independent? It means that the probability of any intersection of any pairs, in this case, is just the product of the probabilities. So it could be probability of A intersect B or A intersect C or probability of all three intersecting. And so let's write this down first. Now, and, and then all three intersecting also. This is the hypothesis basically. You know all this information. And let's see how we want to use this. What we want to show is that A and B union C are independent. That is probability of A intersect that set is equal to probability of A times probability of that set. Um, I like to start with the one with the product and see if I can get to the other side or simplify enough and then simplify the other side and say the two of them are equal. So let's start with probability of A times probability of B union C. And that is the left hand side of what I want to show, left hand side. So what do I know? I know probability of A, it cannot be simplified any further, but I know probability of B union C is probability of B plus probability of C minus the probability of their intersection. And I like that because if I convert the union to intersection, and I know that basically in my hypothesis, that is, I can convert the probability of B intersects C, so I will do that. Now at this point, I want to distribute this over, see if anything familiar is going to happen. So probability of A times probability of B, probability of A times probability of C minus probability of A times probability of B times probability of C. So all of these in the hypothesis have values. And so let's write those values down. Um, First of all, this last one is just the probability of intersection of all of them. The first one is the probability of A intersect B. According to hypothesis, this one is probability of A intersect C. And the last one is the probability of intersection of all of them, according to hypothesis. The right over here. Now let's see. This also looks like, remember, A intersect B intersect A intersect C is just intersection of the three of them. So this looks like the probability of A intersect B union A intersect C. Again, this is the first event, that's the second event, and that's the intersection of the two events. Now, let's use our set theory information. And I know that this probability is A intersect B union C. Oh, what just happened? We basically showed that the probability of the product right here, the left-hand side, is equal to the probability of the right-hand side. And that's what we wanted to show.